strong foundation plays a very important role while building or learning new technologies. Hence, Docker being core component of Kubernetes-based computing, we all must have deeper understanding about the fundamentals of Dockers and containers before we start deep diving into the world of Kubernetes. Because without Docker and container, we cannot even make Kubernetes functional. Hello everyone, this is Atmaram and welcome back to my channel. In this chapter, we will try to decode the concepts and fundamentals of Dockers and containers. We will start with understanding the basic concepts of and functionalities of containers along with its components and operators. We will also try to understand the concepts of Docker and containers by taking some real-world and non-technical references to make it easy to understand and correlate with actual implementations. Going further, we will also set up a Dockerized environment to perform hands-on for better proof of concepts. So without causing any further delay, let's move on to our presentation and start the discussion. In this chapter, we are going to understand the concepts and fundamentals of Dockers and containers in IT and in non-IT terms. We will also try to understand the components of the containers and Dockers along with its operations and one working architecture to further correlate it with the real-world environment. But before we start understanding the technical aspects of the containers and Dockers, let's try to understand the containers and Dockers in general or in non-IT term. As you can see in the images, we have mentioned two types of containers, the commercial containers and the domestic containers, to help you better understand the concepts. You might have seen all these types of containers many times in past. Now, let's talk about the containers first. So containers are the specialized boxes designed to keep the things and goods in proper isolations for ease of management and transportation. Let's assume we have three commercial containers here. One for medical equipment, one for food items, and other for stationery items. With the help of containers, we can keep all these things in proper isolation while loading and transporting them on the same transport medium. Similarly, on the other side, we have domestic containers that we can use to contain multiple different types of eatables in proper isolation without impacting the flavor of one from another. Now you might have noticed that these containers are floating in the water. You might be thinking it was an error, but I kept it intentionally. As you can see, containers, despite being self-sufficient to keep the things in proper isolation, still need some other sort of the platform or system to keep them organized for proper transportation, and these arrangements are called Dockers. Dockers are the platform and the services are used to keep the containers in an organized manner for ease of transportation and operations. It can be a dockyard and a ship or a normal lunchbox to carry the multiple containers. Now let's make the containers little technical. Now let's make the containers and Docker technical and try to understand what is the definitions of the Dockers and containers when it comes to the information technology in IT infrastructure world. As you can see in the image, containers are a small piece of compute instances. We can also call them microcomputer instances. This is used to contain our applications and configurations in complete isolation while being loaded or running on the same platform without impacting each other. So this is the quality of container. Then what are the Dockers? Dockers are the piece of software that runs on top of the physical or virtual compute node to convert a normal node into Dockerized node or containerized node. Doing so enables the capability of hosting, running, and managing the containers. Now let's try to understand these concepts in little more detail. However, Dockers and containers have become one of the most popular computing technology nowadays. But before Dockers and containers, compute technology has passed through multiple stages. Initially, we used to have normal nodes like this. What are the normal nodes? Normal nodes are the combination of CPU, RAM, storage with network connectivity along with operating system that is running on top of it. You might be already knowing the technical definition of the operating system, but still in order to refresh your memory or in order to better understand, because we are going to use the operating system term multiple times in this discussion. So I'm going to redefine the operating system definition. So what is operating system? Operating system is the software suite that has three major types of applications. One is the kernel that is responsible for controlling the functions of hardwares like CPU, RAM, and storage. The second type of software is the user interfaces. User interfaces are going to provide the ability to the users to control the compute resources or the functions by passing the inputs and getting the desired outputs. And because of these user interfaces, we are able to operate the computers. That's why we call them operating system. The third component of the operating system is the drivers. So the drivers are the applications that has ability to control the hardware, additional hardware functions like USB, like network interfaces, like video drivers, etc. These three different categories of the softwares makes an operating system together. Then on top of the operating system, we can install one or more applications which are going to share the compute resources among them. And that is the problem here. That means just because we are having common resources, we are having shared resources that is being shared across the multiple applications without proper allocation and isolation, it is going to create problem. Let's try to understand what is the problem that is associated with this kind of compute technology. The first problem is related to the performance or resource utilization. Let's say we are running three applications, application 1, 2, and 3 here. If application 1 is having any problem or experiencing high load on it, it is going to consume the entire 100% of the available compute resources. That means just because entire resources are being consumed by application 1, application 2 and application 3 are definitely going to experience the lack of resources, are going to cause the performance issue also. The second problem with this kind of compute technology was the isolation. That means if let's assume this application is having some vulnerability, and because of this vulnerability, a malicious actor is able to compromise this application 1. Now just because these applications are running on the same shared medium, shared platform, there is very high probability of application 2 and 3 to be also compromised by the same attack agent or malicious agent. These are the two major disadvantages or problematic situations those were associated with the normal method of computing. And that's why to overcome this problem, we entered in the age of virtualized computing. So what is the difference between the normal computing and virtualized computing here? You can see in normal computing, we had just the compute resources, which are CPU, RAM, storage, and network, and then operating system that is running on top of it. And then on the operating systems, we are directly running the applications. Virtualized computing contains an additional piece of software called hypervisor on top of the normal node that we used to have in past. This hypervisor creates an abstraction layer to host virtual machines having exactly same characteristics of its physical counterpart, along with the ability of resource quota or allocation. Hypervisor can be either type 1 that contains the kernel along with the abstraction application and can directly run on top of the physical compute system without needing any host operating system itself. This is the new word that I am using as host operating system here. I'm going to talk about this in few moments. Then the second type of hypervisor is the type 2 hypervisor. It is just an abstraction application that runs along with the operating system like normal applications. Type 1 hypervisor are a kind of operating system in nature because it contains the user interfaces along with the kernel to control the hardware also. And it does not have any dependency to run another operating system to make it functional. On the other hand, type 2 hypervisors are just like an application which required an operating system to be running on the node before being installed. And once these are installed, it is going to convert the normal node into virtualized node by creating an abstraction layer between the physical and virtual compute resources. Now, what are the virtual compute resources? Virtual compute resources are the logical entity that are created with the help of hypervisor, and it has its own dedicated allocated CPU, RAM, storage, and network. So now let's try to understand how it is going to help us here. So in normal node of computing, we had three applications running on the same operating systems, which is app 1, 2, and 3. Any problem with application 1 is going to impact the other applications in normal computing. But on the other side, when we converted our normal node into virtualized node, we decided to have our application 1 and 2 running on the same system because they are tightly coupled application, and my application 3 should be completely isolated. In that case, what we are doing is we are going to create two virtual machines, VM1 and VM2. What are the virtual machines? Virtual machines are like the compute resources which carries the characteristics of its own physical counterpart, compute node. If you look the virtual machine closely, it looks like the normal compute node in itself because it has its own CPU, RAM, storage along with the network interface plus an operating system. On that operating system, we can install the multiple applications. The only difference is on the normal compute node, the resources are in the physical form, but in virtual machines, the resources are in the virtual form. Now once the VMs are created, we need to install an operating system, which is again the combination of kernel plus user interfaces plus drivers to control the functions of the CPU, to control the compute resources which are allocated to this particular virtual machine. Now once the OS installation done, we have ability to install the desired applications on top of it. Now just because we have application 1 and application 2 is running in VM1, application 3 is running in VM2, any problem with application 1 is not going to impact application 3. However, any problem with application 1 is still going to impact application 2 because they are still sharing the same resources. But it is not going to impact application 3 for sure. So this is the one problem that we solved by creating logical abstraction between the physical node and the virtual node. By doing this, we are able to solve one problem of resource utilization. We are able to dedicate the resources to two different systems. Whatever compute capacity it is having, let's say consider at 100%. Out of 100%, we are going to reserve 20% for the functions of the node itself. The remaining 80% are going to be distributed among these two VMs. Let's say 40% to each. In that case, 40% of the capacity that is available to VM1 is actually going to be the 100% dedicated for this VM2. Any requirement or any problem with application 1 or application 2 is going to utilize all the 100% of the resources that is allocated to VM1, which is actually 40% of the given compute capacity. And in that case, it is not going to impact the performance of the virtual machine 2 because that is completely isolated and the resources are shared and allocated properly. Similarly, the second problem, which is related to security, just because these are the two dedicated compute resources, we can apply the access control to restrict the communication between these two systems. In that case, any compromise with the VM1 is not going to impact the VM2. So this is the second advantage that we are going to have. And that's why virtualized computing was adopted by most of the organizations, and still it is being used at a large scale. So with the help of virtualization technologies, we are able to create abstraction, isolation between the applications. We are able to effectively allocate the resources, share the resources, and still we are creating one more problem here. In the normal node, we had only one layer of operating system here, but in virtualized node, we are going to have one layer of operating system as an host operating system. What is host operating system? The operating system that is directly installed on the compute node along with the ability to host additional virtual machines are called host operating system. And the second operating system that is installed inside the VM is called guest operating system, because that is going to be hosted by the master operating system or host operating system. Now, as you can notice, in normal compute node, we had only one operating system, but in virtualized compute node, because of two virtual machines, we are having one operating system as a host operating system and two guest operating system. And this guest operating system can increase depending on the numbers of VMs that we are going to create. And you can choose the guest operating system. It can be Windows, Linux, or any Mac OS, or anything that you want to use depending on your choice. Now you might have noticed that most of your compute resources are being consumed by the operating system itself. In normal computers, you might have noticed that almost 50 to 60% of your compute resources are being utilized or consumed by the operating system itself. However, this ratio is going to be different when it comes to the server, because the server comes with a comparatively higher capacity and all. But still, it is going to utilize a good amount of compute resources. Now, having more and more operating system running on the same compute node, that means most of the resources are going to be consumed by the operating system itself. More number of virtual machine, that means more number of operating system and more wastage of resources in the virtualized node. One side, virtualization had enabled us for proper isolation and resource allocation. On the other side, most of the compute capacity are being wasted by the number of operating system which is running as in guest operating system, multiple copy of operating system. And because of this, the compute cost was increasing a lot, because most of the compute resources was being consumed by the operating system itself, and in order to make our application properly functional, we need more and more compute capacity to be added to the compute node, and that required compute cost to be increased. And that's how we started realizing the importance of the further evolution in the compute technology, so that we can reduce the resource utilization itself, and the whatever resources and the most of the resources should be available to the applications rather being consumed by the supporting applications or packages. And in order to reduce the cost of the infrastructure and to make the most optimistic use of the compute resources, we started utilizing the Docker environment. And as you can see in the images, Dockerized environment eliminated the need of running multiple copy of the operating system for the isolation and resource allocation. Rather, we are using containers for our applications. And what are the containers that we already talked? Containers are a kind of microcompute instances which are very small in size when compared to the VMs and the compute resources, but it still has ability to run the complete application along with its dependencies, libraries, and configurations to function normally. We urge it used to function with the normal previous technologies. In Dockerized environment also, you can see we have isolated our all three applications into three different containers. Application 1, Application 2, Application 3. Each container is going to have its own dedicated or allocated resources along with proper isolation. That means if any problem in the application 1 or high load on the application 1 is just going to use the resources those are allocated to this particular container. It is not going to impact any other container. Also, any problem, any security threat or risk associated with this application 1 container is not going to impact container 2 and container 3 if it is configured and secured properly. So that means container not only just reduce the cost of the infrastructure, it also provides the clear isolation, optimistic use of the resources along with the appropriate security controls to keep the environment completely protected and secure. That's all in this session. In next session, we will talk about the Docker components and Docker operations to give you better insight into the Dockerized environment. That's all for the day. Hope you enjoyed watching. If you find it useful, please encourage us with your comments, likes, shares, and subscriptions. Thanks for joining. Stay tuned for more videos.